We're starting to get into acceleration, and this is pretty much in normal people words defined as slowing down, speeding up, or changing direction. So anything that speeds up, slows down, or changes direction is accelerating. So this particular equation right here is our acceleration, and the x subscript on there indicates in the horizontal direction. So this is acceleration in the horizontal direction equals the change in velocity in the horizontal direction over the change in time. So you can go ahead and take a moment and read this information here. So when we look up here, this velocity graph, velocity here is positive because it's above the horizontal time axis. So this is positive velocity. This means that this object is uh, moving in a positive direction. Let's just pretend like this object is moving at 2 meters per second in the positive direction. Uh-oh, 3 meters per second. Uh-oh, 6 meters per second in the positive direction. So when you have a velocity line that's not horizontal, so it's sloped up to the right and it's located above this axis, it's speeding up in the positive direction. Let's take a look over here. This one, now below here, the velocity is in the negative direction. So that means that you have something moving at, let's just pick a number here, a negative 5 meters per second. That's pretty darn fast, 5 meters per second in the negative direction. Then here, it's negative 3 meters per second. I know it's negative because it's below the horizontal axis timeline. And now let's say negative 1 meter per second. So this tells you that this object is slowing down in the negative direction. Okay, so with that in mind, the acceleration is still pointing to the right. So we go down here. Let me run you through this one here. Velocity, and if you put numbers to these, it makes it a lot easier. This is 5 meters per second, 4 meters per second, 3 meters per second, and it's in the positive velocity area. So this object is moving in the positive direction, and it's slowing down as it moves in the positive direction. Therefore, acceleration is to the left. Now in this case here, we have an object that's going in the negative direction, and it has a velocity of negative 1 meter per second, negative 3 meter per second, oh, negative. So it is speeding up in the negative direction. So the acceleration is to the left. Go ahead and take a moment, and you're going to look at these vector diagrams and see if you can rank these motions by the order of magnitude. If you want to pause the slideshow, that would be great, because I'm going to forward the slide to the answer. Here's our answer. A equals B equals C equals D. Notice it reads the magnitude of the acceleration. It doesn't say anything about direction. So we're only looking for how big or the size of the acceleration. So anyways, here the acceleration, it's to the right. Here, since the object is moving to the right and slowing down, that means the acceleration is to the left. Over here, the acceleration is to the right because it's slowing down as it's moving to the left. This last one, the particle, the velocity is to the left and it's increasing, so the acceleration is to the left. It doesn't matter if it's to the left or the right, though. That's not what it asks. It asks for magnitude. It doesn't consider direction at all. So when we look at these vectors, the size of the vectors, these are equal. The second one, equal. Third one, equal. So in this case, A equals B equals C equals D. The magnitude of the accelerations are all the same. Okay, try this one on your own. Whenever you're ready, you can hit the forward button. So when we look at this one here for the motion, And we're trying to determine positive acceleration and negative acceleration. So when I see the word positive and negative, we're looking for acceleration to the right being defined as positive, because we define positive in this class heading to the right, and negative heading to the left. So let's see what we have down here. So situation A, velocity is increasing to the right. So that means acceleration is to the right, therefore acceleration is positive. So right down here I have A is positive. The second one here, I have velocity is great. It's getting smaller, 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 smaller. It's heading to the right. So my acceleration is heading to the left. So it's negative. We consider left negative in class. When we look down here, B is negative. So take a moment to look at C and D and see why the answers fall here. So you can reason it for yourself. Pause if you need to. I'm going to forward to the next slide. All right. You're going to try these ones here on your own. I'm going to forward the slide, so you want to pause it and take a moment to yourself. Okay, so here's the solution for this one, and you have to go to each one and determine the acceleration, whether it's positive or negative. We're going to rank them from most positive to negative. So first off, A is acceleration in the positive direction. B, on the other hand, is acceleration in the negative direction, because as this object moves to the right, the velocity slows down or decreases, so there's acceleration to the left. So if you notice, B got put down here in the lowest area and A is in the highest area, since it's a positive acceleration. All right, let's continue. C, here the velocity is increasing as it's heading to the left, therefore acceleration is negative or to the left. So we've put that down here as the least amount, because most negative. So B and C, they're both negative acceleration. That's why they're together down here. We have also, let's move on to D. So for D, we have this object, the velocity is negative. However, it's slowing down as it's heading in the negative direction. That means acceleration is to the right, and it's positive if it's heading to the right. So therefore it goes down here. And E and F, they don't have acceleration at all. You probably recognize this as a constant velocity particle. So E and F gets stuck right in the middle here. Here's a problem for you. And what we're going to do is just look at the velocity of the ball as it travels. So it's letting you know the initial velocity. That V naught just tells you this is the initial velocity, the starting velocity, and it's greater than 0. And it's showing that it's positive. It's heading this way. So the ball is rolling along at a, we'll just pretend like it's constant velocity up here. We'll just say there's no friction. Then all of a sudden it hits the ramp, and you know what's going to happen when it hits the ramp. It's going to speed up, so the velocity increases. And then we'll just say there's no friction down here on the ramp either, or the incline, and it's constant velocity, and it continues on. So the next frame shows you the stat graph. You're used to doing stat graphs for position time and velocity time, but this one is going to be velocity time and acceleration time, so something new and different. Here's the graph, and this is the setup. So I've set it up for you, and I've dotted the different areas where the scenario changes with the velocity of the ball. And here's the solution. If you want to take a guess yourself what the solution looks like before I continue on, pause this show. And here it is. So the velocity increases here. It's getting faster as it's heading in the positive direction. Because remember, velocity up here is positive, indicates the direction of the velocity and the magnitude. Down here, velocity is negative, so it tells you the direction and the magnitude. So moving in the positive direction at a constant velocity, there's no acceleration at 0. Here it's speeding up as it's heading down the ramp, and it's speeding up in a positive direction. Once again, down here there's no acceleration whatsoever, so that's why down here you're showing 0 acceleration. Now this here, since it's a velocity that goes, it increases in velocity over equal increments of time. So this is not a curve, this is a diagonal straight line, and that's why acceleration down here is a flat line. In fact, in this course, all acceleration will be constant. Acceleration will not be changing in this course.